Good morning, afternoon, and evening, everyone. I'm absolutely thrilled to welcome you to the fifth Breathe In Dialogue as part of the Cleaner Air and Better Health Project, also known as the CABH project. The Breathe In Dialogues are a series of webinars with a view of generating a community of people with know-how on indoor air quality issues, concerns, and solutions. The dialogues are held every month around the four thematic themes, which is regulatory convergence, integrated design and technology, monitoring and management, and occupant awareness and communication. These dialogues are curated by us at Environmental Design Solutions, along with our knowledge partner at the Society for Indoor Environment. The focus of today's dialogue is on integrated approach that recognizes the importance of indoor air quality, energy efficiency, and their interconnection. Let me begin with a little brief about the CABH project. This is a 5-year project supported by the USAID with the aim to strengthen air pollution mitigation and reduce exposure to indoor air pollution in selected regions of India. The project is being implemented by a consortium led by the CEW and includes environmental design solutions, ASAR social impact advisors, vital strategies, and envirolegal defense firm. We aim to achieve the project's objectives to strengthen air pollution mitigation and reduce exposure to air pollution in India through consultative processes, evidence-based, and targeted approach. The consortium is working to scale solutions across the states in the country. We are also piloting innovative models to tackle the emissions and air pollution in different sectoral interventions. We are talking about forming an ecosystem that enables adoption of cleaner practices in multiple sectors and between various stakeholders to accelerate their clean air goals. This can be done by creating a result-based impact-oriented playbook to scale solutions and influence the clean air disclosure. All of this is based on a 5-pillar solution map, which consists of enabling monitoring and regulatory reforms, using the data for decision making, sectoral transition to clean energy through innovative solutions, empowering citizens through outreach and awareness, and lastly, equipping institutions with relevant capacity for informed decision making. The Cleaner Air and Better Health project is built on the foundation of innovation, the synergy of integration, and commitment to implementation for a lasting impact. When we consider the impact we aim to achieve, we are targeting a nearly 50% reduction in air quality improvement in the areas covered by CABH through various interventions. It's about creating a legacy for cleaner air and better health. By building solutions that scale and institutionalize best practices, we are ensuring a brighter future for all. I would now like to invite Lakshmi, my colleague, to set the context of today's dialogue. Also, feel free to use the chat functions to ask any questions and give any comments. We will also be having some interactive polls, so do keep an eye on the screens as the session unfolds. Thank you.
Good morning, good afternoon, and good evening, everyone. Today, we'll be focusing on an important aspect of indoor air quality, which is its interconnection with energy efficiency. We know that both of these aspects are crucial to us for our well-being as well as for the sustainability of the buildings we occupy. So it is important to understand their relationship and implement strategies to create spaces that are healthy and energy efficient. On one side, we know that poor indoor air quality can have detrimental effects on our health. And on the other hand, we know that buildings are responsible for significant amount of energy consumption and associated greenhouse gas emissions. And with increasing urban population, increasing building stocks, and more buildings opting for mechanical ventilation, the energy demand is only going to soar in the coming decades. And we see that countries, including India, have been driving initiatives to promote energy efficiency in buildings. So, when we look at energy efficient buildings, we see that they're often associated with insulation, air tightness, and controlled ventilation systems. While these measures can effectively reduce energy consumption, they can also lead to a decreased indoor air quality owing to insufficient ventilation that can result in accumulation of pollutants. So, therefore, there is a need to strike a balance between energy efficiency strategies and indoor air quality strategies. And so, how do we get there? So the solution to this can be seen in a phrase that is very common amongst building designers, which is build tight, ventilate right. Um, this means that as buildings get tighter for energy efficiency, it is important to have ventilation systems that can help maintain good indoor air quality as well. This means that we need regulate. This demands regulations and standards on ventilation and air tightness. Today, we'll hear more about this from Dr. Valerie Leprince. And we also know that technology and innovation can play a vital role here. Advancements in building automation systems, sensor technology, smart HVAC system together can help achieve indoor air quality at a lower energy expense. Now we could have the best ventilation system. We could be putting up the best IAQ technologies in place. But how do we know that they're performing well? How do we know that the data is accurate, consistent, and reliable? For this, there is a need to develop testing and standardization protocols to test these technology solutions. We will have more insights on this from Dr. Andy Dengel today. So, as we move forward, it is important that we recognize indoor air quality and energy efficiency, their interconnection, and focus on regulations and testing protocols so that we design, construct, and operate healthier and sustainable built environments. With that said, thank you so much, and back to you, Dipanjali.
So today, we are honored to have our esteemed speakers, Dr. Valerie Leprince from Cerema and Dr. Andy Dengel from BRE. And thank you, Lakshmi, for giving us a quick overview of, by recognizing the importance of indoor air quality, energy efficiency, and their interconnection. I'd now like to request everyone who has joined us today to participate in the poll, which is popping up on your screens. So, in your experience, when it comes to research or designing airtight buildings, which is given more priority? Is it energy efficiency, indoor air quality, ventilation, or all of them? We'll just wait for a few more seconds for everyone to answer. Excellent. So, okay, so while majority of us do have a focus on all of the above in energy efficiency, indoor air quality, ventilation, I'd now like to introduce Dr. Valerie Leprince, who will not only share her research on the importance of airtightness, as well as the global standards and guidelines for airtightness and ventilation. Dr. Leprince has over 15 years of experience in building airtightness, ventilation, and indoor air quality. She is a key contributor to the energy performance regulation in France, which mandated airtightness test for new residential buildings. She has also been involved in the European standardization of ventilation. Dr. Leprince founded the project for low energy and indoor air quality in 2012 and worked for air infiltration and ventilation center to facilitate tight vent Europe. At Cerema, she focuses on standardization and research dissemination on ventilation and indoor air quality, on indoor environment quality as well. Thank you. So Valerie, the floor is yours.
Thank you very much for inviting me at this webinar. So I will indeed talk about building airtightness, which has been my work focus for the last 15 years, together with ventilation and indoor air quality. So I have a first question for you, just so I better understand what is your opinion about building airtightness. Do you think it's something that is important also in the South Asian building context? I will talk a lot about Europe here, and I would like to have your view about what you think about it in the South Asian context. Okay, so I think we've got, yeah, half of you, which is the yes, of course, so that's very good. And 28% say that it could be good to reduce energy need for air conditioning, and another 17% say probably. So none of you think that it's not important at all, and I guess this is why you are joining this webinar. Second question, do you think that it's more important to work on airtightness in non-residential buildings or more in residential buildings, or to focus in buildings that have ventilation system or those who have air conditioning systems? What do you think is the most important in your context? Okay, so yeah, half of you think it's important to work on all of them, which is good, and 1/3 if they have air conditioning system, and 1/3 if they have a ventilation system. So yeah, I think indeed that's airtightness becomes very important if you've got ventilation system and air conditioning system, whatever the kind of building it is. So I will organize my presentation like that. First, I will explain you how the regulations are made in most European countries and the difference between the prescriptive and the performance approach, and why we are more going on the prescriptive approach right now. Then I will explain you which kind of regulations we have and the reasons behind those regulations, and also the limits, of course. And then I will talk very briefly about the next steps of European regulation regarding indoor air quality, which is the performance approach. So, sorry, here, just one thing to explain what is the prescriptive and the performance approach. Basically, when you do a regulation regarding indoor air quality, you've got two choices. Either you just say, okay, have a good indoor air quality in your building, that's a requirement, or this is the performance approach, or you say, okay, you need to have this flow rate, this level of air tightness, this kind of trickle ventilators, etc., which is the prescriptive approach. So if you make the parallel with what you could say to a taxi, the performance approach is just go to the airport, and the prescriptive approach is turn left at the next traffic light, then the second right, etc. So in most European countries right now, we have prescriptive approach. The problem is with the prescriptive approach is you need to have a good commissioning of the building at the end to make sure that all those aspects are good to guarantee a good indoor air quality. So basically, as we don't have performance in terms of indoor quality, you need to check that the airtightness is good, that the ventilation provides a flow rate, that the door undercut are made, etc., to make sure that you will indeed have a good indoor air quality in the building. So for 40 years now, the regulation, in Europe have been done like that with the build tight and ventilate right concept. You can have a look at this AIVC technical notes summarizing everything about it. I will refer a lot to AIVC documents because most of this presentation is taken from presentation from the air infiltration ventilation centers. So each time I will give you the reference of the documents where it comes from. So build tight and ventilate right. I will explain you the reasons behind and what kind of study demonstrates the impact of air tightness. Also, I will talk to you about regulation and standards regarding building air tightness in European countries, and the regulation and standard regarding the inspection of ventilation systems. So more shortly on this part. So why do we want a good building air tightness? There are multiple reasons for that. some of them due to our climate, some of them that are independent of the climate. So the first one is the indoor air quality. If you don't have a good if you don't have a good air tightness, then you will bypass the ventilation system, and the ventilation system won't work properly. So if you want to ventilate right, you need to have a good air tightness. You may also have odor transports between zones of the building. You may have unfiltered intake air with outdoor polluted air that you may want to filter, and if you've got leakage, it's not filtered. With a cold climate, we also have mold formation at the leaks. We also have, of course, sound transmission, because if the air goes through, the sound also goes through. It may compromise the fire safety with the spread of gas inside the building between zones. With a cold climate, again, it's cause problem of thermal comfort with cold surfaces, droughts, etc. And of course, there is a problem of energy use, because if you've got infiltration of cool or warm air, you also lose cooled and warmed air. You have less thermal resistance in the insulation, and you are bypassing the heat exchanger of the heat recovery. So of course, the user also will increase the indoor temperature because of those discomfort problems. So those are all the reasons why air tightness is very important in building. We have multiple studies showing the impact of air tightness, some of them coming from on-site measurement. With the UK climate, you can improve by 30% the energy used by divided by 3 the infiltration. In the French climate, depending on the climate zone, Mediterranean or northern zone, you can decrease the energy used by 13 to 77% also. Again, all those information are given in a ventilation information paper from the AIVC on the impact of energy policy on building and ductwork air tightness. So the impact is, of course, very dependent on the climate. They are mostly studied in northern country. It would be very interesting to have the same kind of study in India on the impact on the air conditioning. Also, there are studies showing the impact on indoor air quality with the disturbance of airflow pattern, and the impact on building damage with modeling the benefits of having a air barrier. And also, we've got the question of shelter-in-place strategy. Those are airtight building located close to chemical industrial plants. If there is some kind of industrial accident, the people should be able to stay safe inside their dwelling. So they need to have a very airtight dwelling to make sure that the outdoor toxic exposure do not get indoor. So regarding the regulation and standard regarding air tightness, we have done, again, oops, sorry for that, with the AIVC, a series of ventilation information paper of trends in building and ductwork air tightness in multiple countries, so not only Europe. We've got a paper from China also here. You've got, yeah, all the papers that have been done, and this is what I will talk about here. So first of all, just to let you know that we've got mandatory requirements regarding tightness in all those countries that have answered the questionnaire. So France, Spain, Netherlands, Norway, and Latvia, and also in some states in the US. Most of the time, the indicator for air tightness in Europe is no longer the old N50. We used to talk a lot in N50. Now we are talking about QE50, which is basically the infiltration at 50 pascal, so the flow rate when there is 50 pascal difference between indoor and outdoor, divided by the envelope area of the building, and no longer the building volume. So that's the indicator we mostly used in Europe now. Well, in France, we've got something special because we don't include the low flow, but that's, yeah, we like to have our specificities in France. If the building air tightness is well taken into account in our regulation, but in our building, it's because it's well taken into account in the energy performance calculation. Before building a building, you need to perform an energy performance calculation to make sure that the building will reach a certain level of energy performance. This is mandatory in every European country. And the airtightness is taken into account in this calculation. So if you don't test it, you may use a default value that will really penalize the calculation. So you need to test it to prove that you have a good value of airtightness, not to penalize the energy performance calculation. As far as you test it, you need to have, and it's mandatory, you need to have a clear protocol. So in every country where airtightness test has been made mandatory, there are specific protocols that has been developed to explain how to test airtightness in the context of the regulation. So now you see those are basically the percentage of tests that are performed on new building. So in France and in Belgium, almost every new residential building are tested. In Latvia, it's more than 70% of non-residential building. Every country has its own approach. More than 50% of new residential building in the US. And in some countries, they do it by sampling, so it's more like 10%, but still more and more tests are performed in those countries. And so there are also guidelines in every country that has been published to explain how to build airtight building. With all those tests, it's likely over 1 million airtightness tests per year that are made in Europe now. So it's a great opportunity to increase knowledge with statistical analysis of those data. So for example, in France and in the UK, it's mandatory that every test that are performed in the country is recorded in a database. So we are able to make statistics on the improvement of the airtightness over years, and we are able to see how it's changed with time. In the US, they have a big database also at the LB and Lawrence Berkeley National Laboratory, and everything. So if you want also more information about this database, we had a very nice webinar talking about it in January 2021. You can have the recording also of it on the IBC and Tidevent website. Regarding ventilation inspections, we also have a lot of information about it. A lot of requirements about it. If you want to know which kind of regulation we've got in Europe, again, there is a technical note summarizing what are requirements and rationales behind requirements in ventilation. So you can have a look at it on the IBC website. Everything is free, of course. And what I will show you here is the results of a European project where we have gathered information about inspection of ventilation systems in European countries. So review existing regulation, how to build airtight, etc., etc. So there are a lot of protocols that exist in Europe about inspection of ventilation system. Most of the time, it's not mandatory. It's coming into force slowly in Europe, the mandatory inspection of ventilation system, but it's still not made everywhere. You see that it exists in Belgium, in Ireland, Sweden, Finland, and Poland. There are mandatory protocol, but it's most of them are for now, not mandatory. In France, since last year, we now have a mandatory protocol for residential building that exists. So mostly they control the energy performance and the indoor air quality, and or sometimes the acoustic and the thermal comfort with the ventilation system. The problem with the prescriptive approach is that, well, as far as you make a prescriptive approach, you need to check it at the end. And if you check it, you need to make sure that the measurement is reliable and also that the airtightness is durable. So regarding the measurement reliability, when we perform a airtightness test, we've got a lot of questions because of wind, because of stack effects, the pressure is not homogeneous all along the building. So we we may have a big uncertainty on the result of the airtightness test, but if this is a requirement, we need the measurement to be reliable. So we are now in the process of improving the ISO 9972 standards to improve the measurement reliability with all the experience that we have with 1 million of tests we perform per year, to improve, the building preparation, pressure placement of external pressure tapes, etc. And also to limit measurement validity constraints, which is very difficult when you perform a test if you've got a lot of constraint to respect. The question of the durability of building airtightness was also a very big one, and we've got, again, a big literature review that has been published by the AIVC on this subject to see, okay, there is no point in making requirement on airtightness if in the end it just lasts for a few months and 10 years later the airtightness is no longer good. So what we have seen in most study is that basically indeed the permeability of the building increased by 20% within a year after completion and then remain stable. So we are trying right now, we have another research project to find out how we could make more durable airtightness and make sure that the level we measure at commissioning remains the same for a long time afterward. And now, as a opponent, I would like to talk about the performance approach, because now more and more European countries are trying to develop performance-based regulation. So defining requirements on indoor air quality rather than defining requirement directly on ventilation. So just saying, okay, the level of CO2 should be below that, the level of PM 2.5 should be below that, the level of formaldehyde, etc., humidity. And so setting requirements in terms of performance rather than setting requirements in terms of flow rate and air tightness. So this is the future of the regulation in Europe. We had a webinar on this subject one week ago, I think 2 weeks ago, maybe, by the way, with a presentation from India. And you can have an access to the replay if you're interested on the IVC website. Thank you very much for your attention, and I'm free for any question.
Thank you, Valerie, so much for providing a detailed understanding of regulations and guidelines, both prescriptive and performance. So in today's increasingly airtight buildings all over the globe, it is very important to have ventilation systems that help maintain good indoor air quality at minimum energy expense. So moving forward to our next poll, it would be interesting to know from everyone who has joined in, if you have an indoor air quality monitor installed at your workplace, or whether you have ordered them yourself and installed at your home. So yes, feel free to answer the poll questions. And for the ones who have installed and have experience using it, please feel free to add in the chat box as well on what actions or measures have you taken based on the readings. It could, either be a small fix or a complete retrofit. And for those who are interested, having an indoor air quality monitor installed, what are the criteria are you considering for selection of these monitors? Okay, so we have almost 28% saying that yes, they have indoor air quality monitor installed, and 22% almost are interested to install. So which brings us to introduce our next speaker, Dr. Andy Dengel, who leads the testing, research, and consultancy activities at BRE regarding physical monitoring of indoor environment, including post-occupancy evaluation of indoor environment quality and reactive response to problems encountered in occupied buildings. He has participated in collaborative projects with organizations such as BRE Trust, NHBC Foundation, EU FP7, and University of Bath. Dr. Dengel continues to publish in the academic literature and recently served at the DEFRA Air Quality Expert Group, contributing to its 2022 Indoor Air Quality Report. Over to you, Andy.
Thank you. So just to introduce myself. So I work for BRE, the Building Research Establishment, just outside London. My team is called the Environment Team. It's a team of about 15 people, but we basically deal with everything to do with indoor environments. So whereas some of our colleagues at BRE deal with the actual buildings, the construction, the materials, the fire safety, stuff like that, we're really looking at the indoor environmental quality, IEQ, if you like, and that takes in indoor air quality itself, ventilation and HVAC, lighting, noise, and also a load of aesthetic properties as well, things like layout, the situation, location, that all go to affect the occupants. We've got quite a unique insight in a way, because we perform 3 types of work. We do lots of testing to standards or to bespoke protocols. We also do advisory and consultancy work for either commercial clients, for governments, for local authorities, but we also do quite a lot of research. So some of that's commercial. It'll be R&D research on new products that are coming into the market. Other research has been collaborative, as said earlier, with EU or UK government or other funding. So I was going to talk a little bit about some of the new the advances really in sensor and monitor technology, or the proliferation of these sort of devices that are being used. Why do we need them? Well, some of these things are reasonably obvious, but it is true that if you want an absolute measure of indoor air quality, for instance, and get down to the sort of levels you need to, often the equipment you need is very expensive. It can be non-portable. It can be very bulky. So we've always needed smaller technology. So if we can have a smaller sensor or an array of sensors in a monitor, that's going to be easier to do. It may be less costly. It'll be easier to operate. And of course, the advances in IT and sharing data are incredible. So if we can link these things and have smart networks, etc., that's all to the good. A big reason for this, I say, even before the pandemic, I think more people were starting to place a lot more importance in importance in health and well-being, productivity, performance in buildings, and of course, a big part of that is your indoor environment. So people are starting to think of that, and of course, the pandemic's only increased that, and people starting to think a lot more about things like ventilation. Are we ventilating properly? The other driver is certification systems, building regs, stuff like that. A lot of them are now getting to the stage where they're really requiring continuous air quality monitoring data all the time, 24/7, rather than just spot checks. One example of a new standard in the UK is a new British standard, 40102 Part 1, and that really looks at IEQ holistically and requires measurement of a load of parameters: air quality, lighting, noise, etc. So that really needs continuous monitoring by these sort of sensors. And of course, we already know that a lot of things are driven by sensors, things like HVAC systems, building management systems. So a lot of those sensors are already in place. And then, of course, in environmental assessment schemes, BREEAM, LEED, WELL, things like that, are starting to think about having continuous monitoring as part of their setup. Could I have the next slide, please? So what are the hurdles to be able to use these effectively? I think it's true to say that in general, they're going to be less accurate. That's not always the case, of course, and it depends on the sensor. But that always has to be borne in mind. Are they sensitive enough for what we're trying to find? Now, some of the parameters, especially air quality parameters, in the range we need in our homes and offices, are at a very low level, but still have the potential to affect health. So if we're talking parts per billion, rather than maybe parts per million or even percentage, we have to have sensors that can get down to the right level and be very sensitive. That's a little bit different, by the way, from workplace limits. In workplaces where we know there are pollutants around and we can take steps to reduce them or to manage them, we might be working at much higher levels. But for the environmental levels, they're often, as I say, parts per billion. So we need sensitivity. How do we check they're working once they're sometimes installed and embedded in buildings and systems? So that's another potential thing a hurdle we've got to get over. And of course, cross sensitivity, false positives are a real problem and have to be borne in mind, because if we're getting false positives, that's not a good thing. Similarly, if we're not detecting something, we should be just as bad. So sensitivity, selectivity are very important. And if we don't do this properly, you know, we have the chance of having huge IT systems, big arrays of data, but some of the data that's being generated may not be fit for purpose. And we've got to understand what is the purpose of that data and how accurate, how selective do we need to be. Once that sort of data is shared, it can have knock-on effects. So when we talk about gaining environmental assessments, which may then have a bearing on retail value or asset value, but more importantly, if we're dealing with people's health and well-being, we really would like to know what we are sensing or what we are determining is fit for purpose. Next slide, please. So this has made us at BRE, and I'm sure other people think that we really could do with some an easily applicable performance check standard for what I've called low to medium cost air quality sensors monitors. I'm not going to put an actual monetary value on that, but I think we all know what we mean by something that might be reasonably inexpensive as compared to a large piece of equipment, which may be many thousands of pounds. The sector's really looking for a standard for this for lots of reasons. First of all, it can back up the data, but it can also promote sustainability, energy use, but also play into the health of occupants and what we do about that. At BRE, we've got experience of testing some air quality monitors. We've been doing this for several years to bespoke methods, but at the same time, we have developed a lot of test standards, loss prevention standards and building performance standards for things like carbon monoxide alarms, fire alarms, security systems. So we have experience of that. And we know that if we can bring in a performance check standard, that can be used by BREEAM and other EA schemes. First of all, to classify the monitors, but also to reward their use or correct use with credits in a building rating. And of course, we can also verify, hopefully, automatic technologies that are already in BMS and other systems. So if I go to the next slide, over the last months and years, we've been looking at how we do this. And we are now in the first stages of developing a BPS, a building performance standard. And this means chamber testing. So what we're talking about here is having a chamber test protocol. So we'll have a chamber in which we can control temperature, humidity, ventilation rate, and have the experimental conditions and variables reduced, and then test the standard against known temperatures, humidities, and CO2 levels, for instance, in the first place, which are measured by standard or reference analyzers or probes. So, you know, fully calibrated things reference back to a standard. We can then start to look at testing such devices. We've been talking to various stakeholders about this and how this may work, and so far the response has been very good, and it means we're going on to the next stage, which is building a test chamber. Sorry, could you just go back? Sorry, yeah, thanks. Building a test chamber to really further refine the test protocol. We're going to start with temperature, humidity, and CO2 because these are relatively mature parameters. The monitors, on the whole, are reasonably good, and more importantly, the parameters are reasonably simple. They're a single parameter or a molecule in the case of CO2. We'll then look to the more difficult parameters, but just as important. So when we're looking at things like VOCs, which of course there are many VOCs that can be in the indoor air, how do you sense those? How do you get something like TVOC when maybe a standard is only calibrated to maybe one or two different VOCs? So there's a lot of work there deciding how we do this, what the market requires, and how we understand what we're actually getting when we say a low-cost sensor is giving us TVOC. Is it really giving a proper measure of TVOC, when in fact it's probably giving a partial measure, because it will maybe good for the one or two VOCs it's been calibrated against, but of course other VOCs will have different properties and will show different responses. So a whole lot of work there. And when we get to particles, another very difficult thing to do in terms of testing. It's very hard, for instance, to create a test atmosphere of PM2.5. If you're dealing with CO2, you can put in a certain amount of CO2 into your chamber. Even with VOCs, you can put in known concentrations of one or more VOCs, but with particles, more difficult. So there again, there's a lot of work to be done to get to the stage where we could maybe have a performance check standard for monitors that say that they will give us PM2.5 and PM10, for instance. On the right there, you can see where we've done some work looking at sensors just to prepare ourselves for how we would test these things and what size of chamber, how we do it. And bottom right, you can see there, we're looking to do it on a reasonably small scale because that's more economic, a 1 meter cube chamber in which we can control the variables, as I said, and then be able to introduce the test articles in duplicate, in triplicate, whatever the standard ends up saying, and testing them against known levels of temperature, RH, and CO2. And for CO2, we may decide to do more than one level. We may decide to have classifications of sensors depending on what's needed. All that's up for grabs when we go to the next stage, which will be more consultation with a stakeholder group before we get to actually write the standard and hopefully introduce it within the next year or so. So watch this space on that. We're certainly trying to do this because we think there's a real need for it. So if I have the next slide, please. So I've been talking quite a lot about monitoring, as did my fellow speaker, the need to really classify the indoor air quality, be able to measure it. These sensors and monitors are all part of that, and it really plays in to something we've known for a long time, that there are loads of relationships between a building and its users, and of course it depends on what those users are doing in the building. Are we sleeping there? Are we cooking there? Are we playing? Are we working? Are we recuperating in a hospital? Are we learning in a school? Whatever we're doing, it's important the indoor environment helps us and supports us to do that well. We're seeing a lot of evidence, or there has been a lot of evidence that the design and quality of these spaces we spend time in will impact health and well-being. The important thing to remember here is that, and from the case studies we've seen, because I've got to say that part of our work is going into probably the worst cases. We see some of the worst cases where a building is failing, maybe because of an oversight in design, maybe because something that's been introduced into the building, or it could be an outside agency or an outside a weather-related issues. It could be people have built something close by, there's pollution coming from inside. Whatever it is, we see the worst cases where things have gone wrong. But hopefully us and others can feed back into the design loop, into how we design spaces and what we look at in terms of what's important. Because IAQ, for instance, can impact an individual in lots of ways. It can be, in some cases, quite low in effect. So if I'm sitting in a room and I feel I'm a bit stuffy or it's a bit warm, I can often do something about that. I can change what I'm wearing. I can go out of the room. I can turn the heating down, turn the heating on if I'm lucky enough to be able to do that. But of course, in a lot of cases, people don't have the opportunity to do that. And so any effects from poor AAQ can start to impact them. And that starts with sensitivity and irritation, stuff like that, but then gets to much worse effects in some cases. And these can be chronic and they can actually accumulate across a lifetime. There's a lot of work there in the literature, and I've put some references at the end, which you can look at, which say that some of the effects of IAQ that, for instance, we are exposed to when we are young will be with us for a whole lifetime. And a lot of that will be to do with our respiratory system, for instance, but also other things. So it's very important to understand that. It's also important to know that it's not just physical effects, and as well as the actual physical effects, there are definitely mental health aspects here. If people are affected by poor indoor environments, that can have a huge effect on them, and that again is from their general health and well-being, but also in some cases it can be a health and safety issue. For instance, if we don't have a good night's sleep, the next morning we might be more susceptible to have an accident. But similarly, when we're trying to learn or work or do tasks, if either the lighting's bad or there's poor IAQ or the ventilation is poor and the CO2 is high, all those things will affect our performance, our productivity, and then it has knock-on effects. And in some cases, for instance, open plan offices, this can then spread amongst the individuals. So it's very important to remember that a lot's about perception. And I think this general understanding of these concepts and the reason this is important has gone up because of the internet, because of social media, and all the advances we've been talking about. So the fact that you can now very easily go onto Amazon and buy yourself an indoor air quality monitor, that means that people are thinking more about IAQ. They can Google things. They can go and talk to people about it. So it's very important that we're able to sort of match that interest with being able to have a good sense of what's in the air and be able to measure it, and then have some confidence in what that's telling us. It's very important to say also that applied research of monitoring is quite limited when you compare it to, for instance, outdoor air quality. There's a lot of, and quite rightly, there's been a lot to research, and there's a lot of monitoring going on to do with outside air quality in various parts of the world. And all of the reports that I've been involved with say that, but then say that, well, why don't we do more indoors? Because at the end of the day, in many cases, indoors is either the same as outdoors. If we have the windows open or if we have doors open, anything that's outside is going to get into the building. But then the other thing is, if we're going towards more airtight and energy efficient buildings, as my fellow speaker was talking about, we have to be sure that we're ventilating it. So we need more research, more monitoring, I think more awareness of what can happen if we don't ventilate properly. And when you're talking about ventilation, I always say another thing to think about, we think about air quality. Being able to ventilate is important to remove air pollutants. If you have a source of an air pollutant, sometimes you're able to just get rid of that source, or you may choose to get rid of it. If you can't do that and the source is there and it's pervasive, then you need to ventilate it away and say that's very important. The other thing about ventilation is often to do with heat and overheating, because again, if we can't ventilate an indoor space properly, we don't have the ability to reject heat. So the other big problem that goes with in this sphere where we don't perhaps ventilate properly is overheating and excess heat. And we're certainly seeing that in the UK, in a lot of new build flats, for instance, with single aspects, where there isn't the opportunity to reject that heat, and we're starting to see quite serious overheating. So I think you have to look at it in the round. Ventilation is important for so many reasons, and and we need to do it well, and we need to know about it, and we need to react to it. So if I can have the next slide. So again, I have been involved in some reports for the UK government and also the CMO in the UK, one of the chapters of that. And in all of that, when we sort of review what's out there in terms of research and awareness into IAQ, I think there's three times, generally speaking, where we actually look to do some monitoring, some meaningful monitoring of an IAQ in a certain building or space. The first one is, as I said, where someone has become unwell, where there's a real problem, the building owner or the facilities management team may call in, or the health and safety team may call in someone like BRE or someone else to come and have a look, make some measurements, inspect the ventilation stuff, look what's going on, make some measurements and try and make some recommendations to how that might be changed. So that's the first case. The second case is where you need credits for environmental assessment schemes, and there will be some measurements, sometimes maybe not enough, but there is some measurement of some IAQ parameters that form part of that assessment scheme, so you'll go in and measure certain things. And then thirdly, there are lots of quite small short-term research studies, I'm saying maybe 2-3 years, which look at maybe just one building or a set of buildings or a certain scheme, that's fine, but it's not going across the whole building stock, the whole of society. So I think in all these things, we're saying, governments need to support this. We need some focused research, but also right across the building stock, across the society, to look at what are the most pressing issues to do with IAQ. And in that, I think we need to educate people. And this goes right from, I believe, from school age up to actual people who actually have houses or are running buildings. Those affected by poor IQ, unfortunately, as with many things, are those of low socioeconomic status, and also those with poor underlying health or existing conditions. So those are the people we really need to sort of target, but at the same time, a general understanding. And it goes, I think, right through from what we see. We can see people not understanding buildings, and it's not their fault. It could be they're just in an office, they don't understand how that works. It can be in their home. We've seen cases in the UK where people have had quite complicated systems put into their houses. They don't really know how to control them. They don't know where they are. They don't know what to do if they don't work. They might not change the filters. Just some examples, but I don't think we put enough into that. Actually saying to people, we've put this into your house to make things better, but this is how you've got to use it. So as I said, we need to look at what we can do at different levels. Some things are national, global, regional. We can hopefully buy into them by not driving our cars into cities, doing all those sort of things. But other things there is some element where we can have some control, and I think this is where we need to let people know. For instance, can they change a source of air pollution? It could be just by not using a certain product, changing the way they cook, etc. Can they ventilate better? If it maybe they can't afford obviously a mechanical ventilation, but can they use trickle vents in their windows? Can they open doors at certain times? What can they do to try and make things better indoors? But a lot of it, I think, is behaviour and peer pressure as well. So looking at how we moderate our indoor in our indoor settings. I think just finally, I've just left some. If we go to the next slide, sorry. Yeah, so I've just put in some references there to some of the reports that are going on, certainly in the UK, talking about how important it is in terms of health and well-being. I think all of these, you'll find in a lot of those reports, there'll be talk about we need sensors, we need monitors, we need continuous monitoring, but there's always the caveat: is the data fit for purpose, and what can we do to make that data better? So that point, I think I'll stop, and I'm so happy to take any questions going on. Thanks very much.
Thank you so much. I'll now like to invite my colleague Nidhi Gupta to take forward the moderated discussion with Andy and Valerie. Thank you.
Thank you, Dipanjali. Okay, so I think there are a couple of Q&A questions already being asked for both of you, and I see, Valerie, you've already started responding to many of them, but we'll take some of them from here as well. So you spoke about air tightness, Valerie, to a certain question, and I see a recurrent theme coming across because we usually have a lot of naturally ventilated buildings in India. I mean, it's mainly because, our and especially in schools, there's a theme which is coming across that, a lot of children anyways play outdoors, and they spend more or less more time outdoors than indoors. So, in that context, how important is it to actually, convert our naturally ventilated stock into an air-conditioned stock and then tighten it? So would you like to answer to that? Yeah.
Yeah, I guess in India you spend much more time outdoors than we do in European country, where we are like 80 to 90% of the time indoors, so most of the time in your dwelling. But yeah, I would say that tightening a building is important as soon as you put air conditioning in it and as soon as you want to filter the incoming air. If you've got an outdoor environment that is not suitable, either because the outdoor temperature or because of the noise or because of the pollution outdoor, then you will need to check what you are leaving to enter in the building, and so you need an airtight building. But if you've got a perfectly fine outdoor environment with clean air and good temperature and no noise and everything, then you don't need to care about airtightness. But yeah, unfortunately, in most living places now, it's very difficult to have an outdoor environment that is suitable for people. So as soon as it's not suitable, you need airtight building.
Okay. So just another question on that. You mentioned a lot about, performance, moving towards performance-based IQ. How would we go about doing that? I mean, how do you move from that prescriptive to the performance-based way of looking at IQ?
Yeah, well, indeed, we could do another half an hour on this because this is really a working subject. But basically, the approach we have in Europe right now is to keep both in parallel. So we give the choice to the designer either to say, okay, we go with the prescriptive approach or we go with the performance approach. And if you go with the performance approach, then you need to justify through a model, etc., that you reach a certain level of performance in indoor air quality. So this is through simulation prior to the construction of the building. Through, you say, okay, I have done the simulation and I have checked that the target are reached, basically. So this is the approach we have. We are trying to set up in France right now, saying, okay, those are the level you should reach. You should justify it both through simulation. And if you do, it's fine. You can build your building like that.
Thank you. So another question for you, Andy. While the standards for these sensors and monitors are being developed, now as an occupant, do I consider my monitors and sensors, the data that they're giving me, unreliable? Like, because currently, there are no test standards for these monitors and data. To what extent can I rely on these information? Are there any check parameters as an end user that I could, put in place to say that, okay, my monitor is giving me this reading. It seems to be fairly okay. Can you speak to that?
I think it depends on the parameter. I mean, some of the parameters are more mature in terms of sensors. Generally speaking, as I said, temperature, humidity, CO2 tend to be reasonably okay. We get into a few more difficulties when we get to the difficult parameters, like VOCs and particles. Some of the other things like NO2 and ozone, it's almost impossible to sense them at the levels we need to sense them using a small monitor. But going back to all you can do is check that they've been calibrated. Hopefully, look at the small print as it were and see how they've been calibrated. We're hoping that by if these sensors come in, that manufacturers will be hopefully incentivized, but almost forced down the route of gaining certainly a test standard, but then hopefully we can then have certification schemes as well, so that not only do we just test one, we test more than one. We do factory control, make sure there's consistency, and then gradually, hopefully, you'll get to the stage where you have a mark or a label that says that these have a certain performance. But it'll be a long route. CO is a little bit different, carbon monoxide, because carbon monoxide, I think someone mentioned carbon monoxide in one of the questions, but because it's a real life safety problem, there are quite mature standards for testing carbon monoxide alarms. And that they cover all sorts of things to do with, actually, are they accurate? Are they accurate after they've been exposed to a large amount of CO? What if you drop them? Are the electrics okay? There's a whole standards with clauses for those, and quite rightly so. I don't think we need to go quite that far with some of these other parameters, but we do need to have a little bit more confidence in the data. And I can't be specific, but I think you've got to just be careful when you buy something that says TVOC, for instance. Need to know what you're actually seeing, because you won't always give you exactly the right answer. But at the same time, it may be enough to tell you, something's not quite right with indoor air quality, so I'll use that as a screen. So yeah, it's hard to explain how to see how the typical consumer at the moment can get more peace of mind. But so you can just look, hopefully, to see they have at least been calibrated. And
does this require like recalibration after a period of time, or is it once it's installed, I just forget about it?
Well, exactly, and they're the sort of things I think when you start doing standards, you start thinking of other clauses that can't come ahead, and that's a very good example. So, for instance, if we have a standard, we might say you need to retest every 12 months, or replace. So that can become part of a standard. So that's why we're keen to start the process, and then really the stakeholders and the market will hopefully fashion how far that standard goes or can go within the economics, because at the end of the day, as we all know, it will only work if the standard is economic for manufacturers to do, but then they can see that it will give them an advantage in the market, if you like, and at the same time give the consumer more confidence. So yeah, we won't be the only people doing this. Lots of people, but we just think that we need to move towards this, because there's so many things flooding the market, and I say some are okay, some they're just not, because they can't do what they say they do, simply because you can't do it in that size of enclosure, for instance, using the techniques you need to get down to the right levels.
So in that case, considering that continuous monitors are getting developed, the standards are getting developed, in terms of, especially for buildings which are, really large, which are large footprints, public buildings, would it make more sense to consider spot testing? Because there are certain standards for, spot measurements and spot testing. How would you look at that?
Yes, there's two reasons for that. One, it's always good to do, but also if you've got an array of sensors and you can go in and do spot testing with standard techniques, reference techniques, you can cross-check. You can cross-check using a more elaborate piece of equipment on a spot check and compare that to what you're getting on sensors, for instance, while at the same time getting a real sense for the air quality in a certain area that might be important. So yes, absolutely, if you can do that, that's great.
Okay. So Valerie, a question for you. So, there is a lot of research that you've been looking at, and what do you feel are the priority areas of research, especially from a South Asia perspective, where we have these hybrid environments, right? We are not too cold a country. And in terms of even building air tightness or ventilation, build tight ventilation, right? Where do you see the research move forward, or what could be the research areas that would be relevant for our kind of a country?
Yeah, I think we are missing research on the impact of air tightness on air conditioning needs. And this could be a very interesting research to see what is really the potential of energy saving with the airtight building for air conditioning buildings. So in my view, yeah, this is something we have not really done in Europe, because air conditioning was not such a big thing until now. Now it's starting to be with but I guess in India, that would be the main topic of research.
Okay. And you also mentioned, you talked about air tightness and you spoke about envelope. Some of your slides also spoke about ductwork, right? And there could be air leakages from ducts, or so, from that perspective. Are there regulations governing that? Or could you speak to that? Yeah.
Yeah, well, regarding ductwork airtightness, there are a lot of regulation in the US because they usually do, with the ventilation systems, they do both the heating, the cooling, and the ventilation. So when you've got leaks in the ductwork, it costs a lot in terms of fan energy use, in terms of heating, and in terms of cooling. And in Europe, we are a little one step behind here, and we are working on it and trying to put more and more requirement also on ductwork airtightness because that's very important and also source of a lot of loss. And again, I think that in India, I don't know how air conditioning systems are done, but if they are centralized in the building and the air conditioning is done on one point, then it's very important that all the ductwork are airtight because otherwise you will lose a lot of energy. So it's important to work together on building airtightness, ventilation system, and airtightness of the ventilation system itself.
Thank you. I see that we are also closing on our time, but maybe one last question for you, Andy. Okay, or maybe two, and you can just respond to both. So if key takeaways, maybe what could be done to improve the indoor air quality in a home or an office environment, especially considering our areas? And, why do you, I mean, if you're doing proper ventilation, what is proper ventilation?
You mean in terms of homes or?
In homes or other indoor environments, what could be done to improve indoor air quality?
Yeah, as I say, unfortunately, it's very complicated. And it all depends on the situation and the socio-economic factors, etc. But at the end of the day, it's all about trying to first of all understand what are the sources of the pollution. Yeah, so if most of it's from outside, then you have to try and find a way of it not coming in. But at the same time, you need the ventilation inside. So it might be a matter of closing everything up when there's a bad pollution event outside. But then if you're going to mechanical ventilation, you've got to make sure the air you're actually using is properly filtered, and that will take energy, etc. So this is why I think one of the questions talked about hybrid systems. I think in some cases you almost need to have a hybrid and do the best you can. You can use local extracts in bathrooms and for cooking, stuff like that, and then just really sort of try to react if there's a known source, and then you also try and cut down sources that are being actually generated inside or by our activities. And that's easier said than done because obviously we have to cook. We want to do things in houses, but people need to start looking what am I using for cleaning? What am I using air fresheners? If I am, they may smell nice, but are they giving another problem? Are they actually causing a problem? Because in some cases they may be. We've got experience of plug-in fresheners, for instance, that emanate huge amounts of VOC and may sensitize some occupants. So some people might like the aroma, other people it may cause problems. And then it's really sort of looking at the different sources and trying to see what you can address at a certain level. But it's not easy, and it's the biggest problem. One of the biggest problems we've got because, so in so many cases, outdoor equals indoor, and unfortunately, that those who can afford to then air condition or exclude everything from outdoors and keep everything inside, are in one constituency, and then a lot of other people do not have the ability to do that. So that's where we need national, local regulations and initiatives. I think we are seeing some around the world, but they tend to be again in the maybe the more affluent cities, for instance, who can do things like charge people more to use a vehicle inside London, for instance. I'm just using an example, but that's fine. But it only addresses one thing, and again, it's all based on the ability to pay. So I think there's more about behaviours, more about sort of national bodies realising that this problem's not going to go away, and it's only going to get worse unless we start to incentivise building designers and building developers, building users to make things better through design, through behavior, and through regulation.
Right, I mean, you bring out a very important point because there's a lot of affordable housing sector, and there's a lot of mass construction right now happening for the affordable housing segment. And primarily, most of them are are designed to be naturally ventilated. But because of the temperatures not being right and all of them, they could move towards air conditioning, right? And that again is another conundrum again. And having these indoor air quality monitors, solutions, airtightness, all of that becomes a little costly affair. So having regulations in place which actually mandate, that certain things are required, even if certain things are from a design perspective, from a performance perspective, need to be done, kind of sets the baseline for buildings, whether they are affordable or they are for an affluent society. At least there is a minimum standard which is there. Just last question for you, Valerie. Are you aware of any studies specifically in the South Asia country on airtightness and especially its impact on energy savings in these countries? Because
No, actually, no, I'm not. There is the southern study I'm aware of is the impact in Spain. So, but Spain is very, very far from India still, but that's the south, the more south that I have in my literature review, actually. But yeah, I would be very interested to see some study on this subject.
Yes, that would be interesting. Okay. So considering the time, I'll close for now, but the questions that we've not asked yet, we'll be posing them back to you, Valerie and Andy, and if you could respond back, we can share that with the participants. Dipanjali, I will hand this over back to you. Yeah.
Thank you, Nidhi. So yeah, the primary function of building is to provide safe, healthy, and productive, comfortable environments to occupants. So while we continue to focus on energy efficiency, it is important to not lose focus on indoor air quality. So thank you so much. Before we conclude today's session, I want to express our warmest thanks on behalf of the entire CABH team to our experts, Dr. Valerie Leprince and Dr. Andy Dengel, for joining us today and sharing your sharing your knowledge. To all our participants who have joined us, thank you for your active engagement. We appreciate your time, contribution, and commitment. And stay tuned for our next dialogue on our social media platforms. With that, we bring our webinar to a close. Thank you so much, everyone, and have a wonderful day.